So I recently stumbled upon this interesting article written by an engineer at Seattle Times, and he explains how exactly they protect themselves from supply chain attacks. And as you may know, there have been multiple breaches in the NPM ecosystem recently, multiple packages hacked, malicious code produced, and it actually ended up on our computers eventually. And there have been issues with React as well. So this article gives quite a good and pragmatic example that we can actually take and use in our projects as well to secure our projects. So let's start with the fact that if someone hacks our NPM account, they can basically make an update, make a commit on our package and produce some malicious code. And eventually, a lot of products are basically going to pull this NPM package from the NPM registry and then be vulnerable to that attack. Ryan, the engineer who wrote this article, basically refers to 3 different layers of security. And the first one being the lifecycle script management. So what is this? You may not know, but NPM scripts have lifecycle scripts. So pre and post scripts and prepare and pre-publish scripts. So for example, scripts like this or scripts like this ones, if somebody declares a pre-install script or post-install script within the package.json, this is going to run after, for example, you install some kind of a package. Meaning after you do npm install, if one of the dependencies that you just downloaded has a post-install script, then it's going to run this command and it can eventually alter some of the downloaded code or steal something from your computer. Now, what Ryan suggests is kind of hardening this whole process. So he says that npm is vulnerable to that, but pnpm, and actually this article is hosted on pnpm, but I think it's still quite a good example because you can combine npm and pnpm. You can make sure that you download things with pnpm at least, or you install things. So if you do have this pnpm workspace.yaml, you can actually declare this option, strict dep builds, which is going to fail. So the installation or the pnpm install is going to fail if one of the dependencies that you're trying to download has a lifecycle script. Okay, this is very good. And you can also make a whitelist for some of the dependencies if you trust these dependencies. For example, if you're downloading React or Vue or Angular, one of those very well-known libraries, obviously the security is high. And if they want to have a lifecycle script, then it's probably necessary for that framework to have a lifecycle script. So you can kind of skip that. And also, if some of the libraries do have this, then when the installation fails, you can still go manually and there will be some human judgment. You can judge whether the package that you're trying to install has a lifecycle management or lifecycle script and whether you want to allow it or not. If you do want to allow it, it's up to you. It's up to human judgment and you basically ignore these dependencies. Now, the second layer will be the release cooldown. What does it mean? So you can declare a minimum release age. For example, let's say 1 month. And packages that are not older than a month or newer than a month are not going to be downloaded. What does it help? Because you may ask that even older packages are susceptible to breaches, right? And you're right, but older packages have a more adoption rate in my opinion. So let's say if a package has been released half a year ago, more people are using it, meaning if there's a breach for that version of the package, then more people will be involved and the faster the issue is going to be resolved. While on the other hand, the newer package that has been released just yesterday may not even notice that there has been a breach. And how do you even notice that there is a breach or not? And by the way, this is not sponsored at all. There's a thing that you can use called Sneak. It's one of those platforms. It used to be called Ment, but then it got acquired by Sneak. So what it's going to do is basically you're going to integrate it into your CD/CI pipelines, and it's going to scan all the third-party dependencies that you're trying to install. And if there's an CVE, so if there's a vulnerability in one of those packages, then your pipeline is going to fail, and then you either need to update the dependency or not. And going back to the dependencies, of course, if you need to do a hotfix, you can again exclude a specific version of this package, and then you're good to go. We also have trust policies, and this is kind of the third layer. What is this? So NPM has different trust policies. The best trust policy are the packages that were published, for example, via GitHub Actions, and they have OIDC tokens. And this means that the package has been published in a secure manner. This is like a proven person that has done that. Second one is basically signed from a CI/CD pipeline. And the third one, where you don't have evidence, is probably the worst, is that the package has been published with a username, password, and token authentication. So you can actually declare that there shouldn't be any downgrades. So this will be the key, and this is the value that you can declare in your package JSON, and or rather pnpm workspace YAML, excuse me. And then if there was a downgrade, for example, the first time the package was published with a trusted publisher, and then the update for some reason comes with no trust evidence, obviously pnpm is going to scream and not install this package anymore. And this is kind of a clue that there have been a breach, or there might have been a breach, because the hacker is probably going to publish it without a CI/CD pipeline, but rather with no trust evidence. Now, I also want to mention that some companies are using this thing called Artifactory. And what Artifactory is going to do is, for example, you have your local machine here. So machine, you're going to have Artifactory in between. And this is just one of the products, Artifactory. Again, no sponsorship. And then npm is going to be somewhere here. So Artifactory is going to be your kind of a middleman. What's going to happen is that every time you install a package, it's going to go through Artifactory. And then on the way back, it's also going to go through Artifactory. And Artifactory might have some extra security policies like scanners and so on. So it's going to scan those npms that are coming back, and it's also going to cache them so that the next time you do an install, it just fetches them for Artifactory, which is much faster. So I guess this is it, guys. If you like this video and if you think that this is something viable to go and implement by yourself, let me know in the comments below, and I'm gonna see you in the next one. Don't forget to subscribe, and goodbye.